The future of enhancing memory through technology. Why memory enhancement feels both exciting and uncomfortable. The idea of improving memory through technology sounds exciting at first. It feels like something that belongs in the future. But the early versions of this future are already being explored. Memory is not just storage. It is connected to identity, emotion, learning, and personal experience. So this raises a question. If technology begins changing memory, are we only improving a brain function? Different types of memory involve different brain systems. The prefrontal cortex helps organize and retrieve information. The amygdala can attach emotional importance to memories. Long-term memories also involve distributed networks across the brain. This is interesting because memory enhancement cannot be as simple as pressing one remember better button. Technology would need to influence complex circuits, timing, attention, and neuroplasticity. Why technology is already connected to memory. Calendars, reminders, notes, search engines, photos, and voice recordings all act like external memory systems. In a way, humans have been outsourcing memory for a long time, but future memory technology may go further than external reminders. It may directly interact with the brain's own memory systems. That shift is important because it changes technology from something we use outside the mind. Assignments, birthdays, passwords, directions, even random facts. Sometimes that is helpful, but it also makes you wonder what kind of memory we are strengthening and what kind we are weakening. If every piece of information is instantly searchable, it is just a different relationship with memory. Techniques like transcranial magnetic stimulation, transcranial electrical stimulation, and deep brain stimulation are being studied for their effects on memory-related circuits. These technologies may influence neural activity by changing how brain regions communicate. The goal is not to create perfect memory instantly, but to improve memory function in specific situations, especially when memory systems are damaged or weakened. Why timing matters in memory enhancement. The brain has to encode information, consolidate it, and retrieve it later. If technology is going to enhance memory, it may need to interact with the brain at the right moment. Stimulating the wrong area at the wrong time may not help and could even interfere with normal processing. The role of neuroplasticity. Neuroplasticity is the brain's ability to change connections based on experience. Most learning depends on this process. Future memory technologies may work by strengthening plasticity. This is interesting because the technology may not replace learning. Memory prosthetics and brain-computer interfaces. Some researchers are exploring memory prosthetics, which are devices designed to support or restore memory function by interacting directly with neural activity. Brain-computer interfaces could also play a role by reading patterns of neural activity and helping reinforce or reconstruct memory-related signals. If memory depends on patterns of neural communication, then understanding and influencing those patterns, artificial intelligence may become important. Neural activity patterns are not simple or easy to interpret manually. AI systems could help detect patterns related to successful memory formation, predict when memory is weakening, or personalize stimulation for individual brains. The difference between enhancement and treatment should be used mainly for treatment or also for enhancement. Helping someone recover memory after injury feels very different from helping healthy people gain an advantage in school, work, or competition. Would it increase inequality? Would people feel pressured to use it just to keep up? Those questions matter. Why perfect memory may not be ideal. People often assume better memory is always good. But forgetting has a purpose too. The brain does not store every detail forever, because that would probably become overwhelming. Forgetting helps reduce mental clutter. So if technology improves memory too aggressively, it could create problems. The goal should not be remembering everything. It should be supporting useful, healthy memory. The part that feels most human. Memory is deeply personal. That makes memory enhancement more sensitive than improving speed or strength. Changing memory may affect how someone experiences their own life. That is why this topic feels different from ordinary technology. It touches something very close to identity. What the future may actually look like. The future will probably not begin with people instantly downloading knowledge into their brains. It will likely develop more gradually. Better cognitive tools, personalized learning systems, wearable devices that support attention and sleep, brain stimulation therapies for memory disorders, and eventually more advanced neural interfaces. The real future may be less dramatic than science fiction, but still extremely important. Final thoughts of brain stimulation, artificial intelligence, neuroplasticity. wearable tools, and brain-computer interfaces. But memory is not just information storage. That means memory enhancement has to be handled carefully, but supporting healthier and more reliable memory when people need it. Once you understand how complex memory really is, the future of memory technology feels less like a shortcut and more like one of neuroscience's most delicate challenges.